take a look at here is an antibody screen. So this is initially run on the patient just to see if they have any, you could say, non-ABO antibodies present. So just looking at patient A here, we can see that in this panel screen we have two sets of fluid cells. And on the right, you can see here that the first cell is negative, 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 and the check cells, and the bottom one is actually positive. It's positive at the G phase, right? We have the initial spin, 37 degree, and the anti-human globulin phases. Those are the three that we're screening, which is check for information. So if the patient has a positive screen, as this patient does,
I have a caption.
It's actually
yeah.
We take a look at our identification panel. We can see that we have on the left, we have our vials, we have 1 through 10, and then we have TC.
Can you see them now?
Yep. Yeah.
Basically treated as the 11 vial. So, whenever I do an identification here, we can see in this panel screen, 2 vials, 2 sets of fluid cells. And on the right, we can see here that the first cell is negative, 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 and the check cell is checked out. And the bottom one is actually positive, and it's positive at the AHG phase, right? We have the initial spin, 37 degree, and the anti-human globulin phases. Those are the 3 that we're screening the truth check for information. So if the patient has a positive screen, as this patient does, then more than likely a patient or a antibody identification panel is going to be done. And as I mentioned here, the screen only has 2 vials. Now, if we take a look at our identification panel, we can see that we have on the left, we have our vials, we have 1 through 10, and then we have GC technical cells, which we're just going to basically treat as the 11 vial. So, whenever I do an angiogram, which I guess I haven't mentioned yet, that this piece of paper in front of me with this antigen profile called the antibody. And whenever I have completed all the testing, and you can see that this is completed, and we did 2 testing on this. On the right-hand side, we have our initial spin, 37 AHG check cells. And you can see that this has all been completed with 0, which are negative reactions, and then, of course, creative positive reactions. So here's what I do when I'm trying to work through one of these things after I've done all the testing, is I just have a general look over the whole thing and just look at kind of some key features. So the first thing I'm going to look at is down here we have the patient cells. So this is what is basically also known as the auto control. So that is where we are combining patient red blood cells and patient plasma, and just making sure that there's no autoinflammation going on. And in this particular patient, we have 0, 0, 0, which means negative across the board for all 3 phases there. So we feel pretty confident that we don't have any interference and false positives in any kind of autoantibody. All right, now if I look here on the right-hand side, I can see that I have no reactions at initial spin, no reactions at 37, and then I have a 3+ and another 3+ at the AHG phase. So this gives me some, some information that, if we're just looking at a single antibody, it seems to be more of an IgG antibody, because we know that IgM antibodies tend to react at initial spin, and IgE tend to react at 37 degrees or at the AHG phase, and that seems to be what's going on here with this particular patient's plasma. All right, so what I'm going to do is I'm going to circle here the positive cells. So this vial of cells, that's number 2, had a positive reaction, and then number 7 also had a positive reaction. So we just have 2 of them. So hopefully we're just dealing with a single alloantibody here. If there was, more reactions going on, it would complicate things. But right now, it's looking like it probably is going to be fairly straightforward. Okay. So when we do this, you have all these boxes, all these pluses and minuses. I always like to use a piece of paper or a ruler or something to keep me on task, keep me on the right line, right? Because it's very easy to get mixed up with these things. So what we're going to do here is we're going to look at the negative sides or the negative vials. Vial 1 is negative, and we're going to go ahead and cross off the positive antigen. Now, when it comes to how you cross out the antigens, there are different attitudes and methodologies and procedures for how to do this. So the way that I am doing it is the way that I teach my students, and it's not the only way. So if you are a student of laboratory science in our blood bank, you follow which is instructor or the clinical science standard operating procedure. You follow whatever they guidelines that they use in their facility. Okay, so what I'm going to do here, like I said, we have negatives over here. I'm going to cross out the positives. Now, if you're already doing antigrams and antibody identification, you probably have heard of dosage. So what dosage is, it refers to the genetic expression of an antigen. Either an antigen is heterozygous or homozygous. So, for example, if we look in the Rh system, we have D. There's only one D. So that's a homozygous. It's a homozygous expression. And if we look at big C and little c, well, those are split. Those somehow affect each other. So, if we have a plus big C and a plus little c, that means that each of them are showing a heterozygous expression of that antigen, and therefore that antigen expression being weakened. Now, in this case, in cell 1 here, we have big C has a plus and little c has a 0, so we say that big C is homozygous all by itself, and therefore it's probably expressing itself strongly as it can. So we have to take this into consideration when we're crossing out our antigens. So with D, since it's by itself, I know that that's a strong reaction. I'm going to do a double cross or an X. And that's going to tell me that basically there's no way that our antibody that's showing a positive over here, that can be big B. Because we have it's negative here, and it's positive here, and it's a strong expression, so we're just going to cross it off. Now, when it comes to other antigens, like I said, big C, little c, big E, little b, we are also going to take why am I gapping already? Dosage into consideration. Sometimes this happens when you're on camera. And actually, we're going to treat, this is, once again, this isn't there are differing opinions on this. Some laboratorians believe that only certain antigens you need to have dosage taken into consideration, whereas other laboratorians think you have to take dosage.
Okay, I don't want to get into a whole bunch of dosage and stuff yet because I think that's just a little advanced for what y'all need to know for this chapter.
I didn't understand any of that.
None of it? Okay, we'll go over it too, but I think that's a great video to see it as we're talking about it. And so I tried saving some pictures and stuff too that I'm going to try to incorporate. And I'm actually going to try. Oh, go ahead.
Can you give us the name of the video? Because the sub-captions are way too fast.
Yes. Let me.
And then I can go back later and pull that up.
Yeah, so it is called Blood Bank Antibody Identification 1. And it is by, let's see. By Pat Tracy. Let me share this with y'all again. So it's on here. Share. Blood Bank Antibody Identification 1 by Pat Tracy at Wenatchee Valley College. Say that 3 times fast.
Yeah.
Okay. Now, so I'm going to give this whiteboard thing a shot. And y'all are just going to have to bear with me.
All right.
If this doesn't work, I'm going to go back to the,
All right.
what's it called? Word document.
I gotta get over here. Just killing me.
Stop sharing. Pin out. Okay, so I'm try. Text antibody. Antibody screen. And antibody screen and ID. So oh, those are all circles. Don't want it like that. Okay. Hey, it made a happy face. Okay, so antibody screen. The difference is your antibody screen. Oh, no, that's not working very well at all. Good word. Word it is. Sorry.
Looks like a kid.
I know, I look like a kindergartner there. Okay. That is not going well. Let's see. Share screen. Dude, this is nice to be able to do this from like beds and
I know.
comfy spots. Okay. And I do. So your antibody screen, what does that sound like? Does that sound like more in-depth or less in-depth?
More in-depth? More
What?
in-depth?
A screen versus a panel. Which one sounds less in-depth?
Wouldn't your screen be less in-depth than the panel?
Correct. So your screen's going to have 2 to 3 different cells. So you know how you have like a little bottle for each one. You know how Kim gave you that like set of 3 red ones?
The antigen 1, 2, and 3?
Yes, 1, 2, and 3. And then you have a little packet that goes with it that you're supposed to guard with your life.
Right.
Ringing a bell. Okay, so that's your antibody screen. And then your antibody panel is going to have 10 to 20 different cells. And now here's an example of each one. No dying during this tutoring session, okay? Same rules apply. as on campus.
Okay.
You have to wait until after. Green. Let's see what I got here. Okay, so here's two examples of antibody screens. So we've got our one here that's like your antigram for it, which is where you record it. This one has them written in, but normally like you go and write in the results. So this is the antigram, and this is like an example of what your 1, 2, and 3 look like. So they're going to be a cell, red cell material, and not like your antibody. So what's that going to have in it? Known antibody or antigen in these antibody screens?
Antibody?
Why? What color are they?
Red. Antigen, because it's on the cell.
Okay, now an antigen is going to be inside of these. And so here's your other example. And this is a little chart just like this one. This one's just a little larger for you. And then we'll go down to antibody panel. And I had a harder time getting a picture I liked for this one. I'm going to crop it real quick. So an auto control should be run with all panels, and we'll talk about that in a little bit too. But for right now, I just want y'all to see like what the panel would look like. Okay, let me bolden this up a little bit. Y'all kind of tell, you can read that?
Yeah.
So down here's your antibody panel. So the difference is instead of 3 sets, you've got, 10 to 20. This one happens to have 11. And what you'll do is you'll go and fill them in for each one the same way you would the antibody screen. Okay, now your antibody screen and ID. So is made from or uses commercially prepared. Do you know which group red blood cells?
What now?
What group of red blood cells, like AB or O, do the antibody screen ID reagents use?
AG?
Nope, they're going to be group O RBCs with specific distribution with blood group antigens. So this right here will most certainly, and if it's not, they can fire me because like this is most certainly going to be a question though. Your antibody screen and ID, what group red blood cells they use, and it's commercially prepared group O. So remember group O red blood cells. Now, for your screening cells, and it's the same process for your antibody screen versus your antibody panel. It's the same except for how in-depth you go and how many are included. Make sense?
Yeah.
So this screening or panel, cells. So we are going to start with what we are testing or looking for. And we're trying to find, what are we trying to find? Patient antigen or antibodies?
Antibodies. I mean,
Yep.
antigens.
No, you had it right.
Oh,
Don't forget, antibody screen. Antibody screen, so we're looking for patient antibodies, which would be unknown what? Because we know our patient means that it's unknown, it's not a reagent, and their antibodies are where?
In their serum.
Yep. Okay, so now we need the opposite to start with reagent-wise, correct? It's just like the forward and reverse typing. So now we want the opposite, which is going to be our what? So we take our, we're looking for a patient antibodies, which is an unknown serum. So we take our patient or donor serum and mix it with, what's the opposite of that patient or donor serum? If we have our unknown serum, we need a known, what, antigen?
Antigen.
Uh-huh. So what is our known antigen?
Red blood cell.
Uh-huh. And is it reagent or patient or donor?
Patient and donor.
For known? Because for our antibody screen, we're looking for patient antibodies, which we know is unknown serum. So what is the opposite of that? So we know it's going to be a known antigen. So which one is your known antigen? That you for sure know what's inside.
Your RBCs, your blood.
Yep, your red blood cells. But how do you know if it's known or unknown?
Whether it's yours or transfusion.
Nope, whether it's reagent or patient or donor, correct?
Right. Okay.
Same page? So you're going to take your patient or donor serum and mix it with reagent red blood cells, which in this case happen to be your either screening, so 3, or I guess 2 to 3, or panel, 10 to 20 cells. And they'll be numbered on it like that. So like here, up here, where it said, like, see, you've got the Roman numeral 1, 2, and 3.
Right.
So that's your screening cells, and your panel will also have them all numbered. So that's what you mix it with. And then you're going to test them at various phases. So you know, some you just test at initial spin, and some at 37, and some at AHG. So you test at various temperatures. So your initial spin. Initial spin. Are y'all good with IS at this point, meaning initial spin? Or do you want me to write it out?
That's fine. I can write it out.
Put it in once and then. Okay, so your IS is going to be for mainly IG what?
Your what now? What did you say?
Which immunoglobulin is your initial spin most likely going to be?
IgG.
For initial spin. So this is like room temperature. Which one's most clinically significant?
IgM.
No, most clinically significant.
Was it the
Across the
IgG?
placenta.
IgG. I said that first.
Oh, sorry, I didn't hear the IgG. That's my bad.
I said that first, and I thought, okay, that's not right. So
No, IgG. So IgG crosses the. Well, no. This is a different question. Sorry, you said it first for that one. It's not IgG. So IgG is the most most clinically significant. Why is it clinically significant?
why is IgG most significantly
Clinically significant. Because it reacts at
the fetal?
reacts at what temperature?
Oh,
Makes sense. So, IgG.
37.
37. Which is body temperature, right?
Right.
So that's going to be down here for your. I don't know why it's taking it down. Spin. Okay, so initial spin is going to be your room temp. And now your 37 is what again?
Body temperature.
Body temperature. And so that's going to be IG. What's most clinically significant?
IgM. IgG.
Yep, IgG because it reacts at body temperature. So if you ever can't remember them, remember that IgG is most clinically significant because it reacts at body temperature. Which is 37 degrees. So if you can make that connection, you know that where that one's going to stand. So if that one's IgG, what is your initial spin going to be?
IgM.
IgM. So that's going to be your room temp. And then you've got your AHG or IAT. And that'll have its own little category. And then you've got check cells, which you run if it is what?
Negative.
Negative. Yep. So if you get a positive at 37, do you run check cells?
No.
If you get a positive at initial spin, do you run check cells?
No.
If you get a positive at AHG, do you run check cells?
No.
If you get negative at every single one of them, do you run check cells?
Yes.
Good. So we're going to test it at various temperatures. And then you need an auto control. Now, don't get your auto control confused with your check cells, which is usually recorded as CC. So let me put CC first, so it looks the way the other ones will too. And this one I'm going to put. So, and then we're going to have an auto control that we're going to run the entire panel on like it was a patient. So up here, your auto control is going to be down here. And that's why I put this picture in so it could point it out when we talked about it. So your auto control is going to be your patient red blood cells plus your patient serum. And we'll go over that in a minute. But so here's your cells in the normal panel. But what you're going to do down here is have an extra row, and that's going to be your auto control. So then we're going to do, I'm going to make auto control. And your auto control is going to be your patient serum or plasma tested against your own RBCs. Against individuals. Patient RBCs. There we go. I like that better. So here you got your patient red blood cells plus patient serum. And you take that all the way across. And what is that? Let me see. The goal of your auto control is to determine presence of what? What does auto sound like?
Oh, wait. Like auto-antibodies, so antibodies against themselves?
Autoantibody. Yep. So your auto control is to determine the presence of an autoantibody. And now you need to know how to determine the results of this auto control. And so if it's positive, it may indicate a delayed transfusion reaction. Now, there's another option. So if positive, along with all of the panel cells, an autoantibody is indicated. So if you just have a positive auto control, it could be a delayed transfusion reaction. But if your auto control is positive and every single one of your panel cells are positive, you might be thinking it's an autoantibody. Yeah.
Someone else over there.
Looking comfortable there, Michelle?
Yeah, I had to. My legs were cramping. When you sit up in that little cross leg style, I had to. My legs
No,
were
I just had to
cramping.
uncross mine because they were like losing feeling.
Yeah, it's kind of like I gotta just.
All right, I'm trying to get there. Make sure I covered everything. Good group. Mine goes in a slightly different order, so I've got to. Here we go. Okay. Have y'all talked about naturally occurring versus immune alloantibodies or naturally occurring alloantibodies? Terms ringing a bell?
Mm-hmm. Let me see.
We do the sensitized cells and the protonators and the bovine serum.
One more time. What?
The IgG sensitized cells,
Okay.
the polypacific AHC,
HC. Okay.
and then the Potonators, does that sound P-O?
Potentiators.
Yeah. Potentiators.
Okay.
And the bovine serum albumin.
Albumin. Okay. Give me a minute.
And then it goes into lectin.
Okay. Yeah, and I've got those saved.
Yeah. So how does the homozygo and heterozygous
Heterozygous and homozygous?
yeah, how does that relate to this? That's what's confusing me.
Just a second.
Oh, there's the antigens, but that's
Okay, so specifically for this, your homozygous versus heterozygous has an effect on the result of how much like an antigen is going to be affected. So let me start with a little bit about antibodies, and then we'll get to that here in just a second, okay?
Okay.
So antibodies, the purpose of antibody screens. So this is more the testing of it, the process. So purpose of antibodies. And y'all understand when I'm referring to like a screen, the screen and the panel is pretty much the same in regards to information-wise about it. We clear there?
Right. Has more than the other.
Yeah. But generally, like they're the same. When I talk about an antibody screen, that can be like following the antibody panel too. Unless I'm like specifically separating them. No, not me. Okay. The antibody screen, the purpose of the antibody screen and panels is to detect unexpected antibodies approximately 0.2 to 2% of the population has these antibodies. So that's still a pretty low amount, right?
Right.
0.2 to 2%.
Right.
And now they can have different classifications. They can be immune. So that's the result of red blood cell stimulation in the patient. They can be passive. What sounds passive?
What?
What sounds like it's passive? What kind of event might happen where you can have passive antibodies given? Where you can come in contact with these, where your body, with the antigens, where your body would want to make antibodies against it.
During a blood transfusion or something?
Yep.
Oh.
Through blood products or blood derivatives. Like transfusion. And then there's some that are naturally occurring. There we go. I had the C right the first time. There we go. Occurring, which is environmental result of environmental factors. And now they can be, alloantibodies, which means what? Where is it directed? Directed
At you? Same person?
nope, allo. That's okay. So your alloantibodies are directed at foreign antigens. And so your auto antibodies are going to be directed at what?
At the same. You.
One own antigen. Now you've got your clinically significant. Antibodies. And now overall, basically what that means is not a specific like going into like IgG or anything like that, but clinically significant antibodies is one that results in the shortened survival of what? What do you not want the survival to be shortened in? Think about what's breaking down during transfusion reactions, during hemolytic.
Antibodies.
What?
You don't want your antibodies to break down.
A little broader than that. What
Your immune
what valuable part of your body do you want to stay the way it is?
Red blood cell.
What, Lily?
Red blood cell.
Red blood cells. So, a clinically significant antibody is one that results in the shortened survival of red blood cells possessing the target antigen. Meaning, if your body sees it, it's gonna clear out those red blood cells and hemolyze them. So these are generally IgG antibodies that react at what temperature for IgG?
IgG would be
Are you talking about temperature?
Uh-huh.
It would be your body temperature.
Yep, which is what?
37.
Perfect. So they're going to be IgG antibodies. They react best at 37 degrees Celsius or at your AHG phase. They're known to cause hemolytic anemia or hemolytic transfusion reactions in HDFN. So HDFN and hemolytic transfusion reactions. And now we went over our screening cells that are commercially prepared group what? Your screening reagent cells? Group.
What was the question again?
What group, what blood group are your reagent screening cells made from?
O?
Oh, yep, group O. So your screening cells are commercially prepared group O red blood cells. They're obtained from individual donors who phenotype for the most commonly encountered and clinically important red blood cell antigens. Red blood cells from, now we're getting into our homozygous versus heterozygous. So antibodies. Fingers away off this words. So, go ahead and have Michelle remind me. Let me fix a couple of things.
I'm going to be right back. Let's turn my phone on real quick.
Okay.
Yeah, that feels better. Okay.
So, can you briefly tell me, or you can look it up in your book, whichever one you want, Michelle, tell me the definitions of homozygous versus heterozygous?
Okay, give me 2.
You're good.
Give me 2 seconds.
You're
I just had, okay. Okay, so homozygous, I don't know, I can't say that, is 2 allies for
allele? Okay,
yeah,
cool.
2 alleles. So 2 alleles for a given trait or are identical.
Great.
Not or. Take
Just
the or. Take the or out.
hey, baby. I will in a little while, in about an hour. Okay. They're not going to be here that fast. Hey, I gotta go, okay? Okay, love you, bye. My son insisted we ordered super wings off Amazon last night. And like with the whole virus thing going around, Amazon's taking longer than like the 2 days. So it's not gonna be here till next Friday. And so he's at his dad's today because he wasn't feeling well. And he's like, well, can we get them sent here instead? I'm like, I'm getting you in an hour. They're not gonna get there in an hour when they're supposed to be a week from today. Okay.
Out the or.
2 alleles for a given trait or identical.
No. It's 2 allies for a given trait are identical, not or.
Okay. Are identical.
Okay, heterogeneous.
Heterozygous. Yep. You'll get there.
2 alleles for a given trait
For a given trait
that are different.
or different. So what is let me see what a good blood bank example would be. Can you all see the internet page or no?
Not yet.
Okay. Give me just a minute and I'll. Do you still see the Word document?
Yeah. So that would mean 2 things that are in common would be the same.
I think Kel is the biggest one. Sorry, what?
Wouldn't it be that like 2 things that are in common would be the same, and 2 things that are not in common would be different?
Okay, so let me show you like specifically for Kel. Ooh, this one's good too. Just a moment. And then I'm also going to show you one for like ABO. Oh no, that's not right. Okay, I'm coming back. Am I moving the page?
Yeah.
Yeah.
Yeah? Okay. So for homozygous and heterozygous, actually they're both going to be on the same one. Put it down here. Insert. And okay. I wonder if I can, I bet I can put them over here. Just a minute.
I won't let you drag it beside it.
I'm working on it. Just a second. Okay. Seems like the best I can do right now.
That's fine.
This is going to bug me. Okay. So for for Kel, you've got your big K and you got your little K, or you can have just little K, which is going to be recessive, which is your little K, and this is your Punnett Square for it, or like your antibody screens, homozygous versus heterozygous. So I think the easiest one right now, since y'all don't know a whole lot about Kel yet, is going to be your ABO, because you know more about your ABO. So if you have, this is from, let's say this is from mom and this is from dad. And again, they can be reversible. This can be from mom and that one can be from dad. What is this? Homozygous or heterozygous? Your AA.
If they're
an A from mom and an A from dad.
Would it be homo?
Homozygous. How about AB?
Hetero.
Oh, you're
What?
talking about this.
You're correct. What was it again?
Hetero.
Hetero?
Homozygous.
Yep. How about AO?
Hetero.
Hetero? Heterozygous. How about AB?
Hetero.
Hetero. How about BB?
Homo.
Homozygous. How about BO?
Hetero.
Hetero. How about AO?
Hetero.
BO?
Hetero.
And OO. What?
Homo.
Homo. Yep. And now up here, these two are homozygous, right? But they're homozygous recessive. So OO is going to be your homozygous recessive. And then your like AA and BB are going to be your homozygous dominant. And now, now that you have that information, where it comes
Are
into
they
place.
recessive?
What?
Why is OO recessive and not dominant?
I don't know. It's a recessive trait. I think you'd have to get into a lot more biology than I pass for
Okay.
the genetic aspect of it, but we generally know that type O is recessive, like blue eyes are recessive, things like that. Now, where it comes into play with antibodies is red blood cells from a homozygous individual have a double dose of a single antigen. So I put results from the inheritance of two genes coding for the same antigen. If I erase that and put, what is it, codominant? Should I leave it that way? Is that confusing? Let me put in mom and dad.
All right.
So that now you know where you get your two genes from. So heterozygous, RBCs, a heterozygous carry how many? How many genes code for the same antigen?
1.
What?
1.
Yeah, only a single dose for how many antigens? Do they have less antigens?
Yeah.
No.
Oh,
They have
more?
the same amount of antigens, but like for a homozygous, it's a double dose of the same one, whereas RBCs from a heterozygous individual carry only a single dose of two differing antigens. Of two differing antigens. So in this case, results from inheritance of two genes coding for different antigen. Still one from mom and from dad, one from dad, except for mom gave one and dad gave a different one in heterozygous, whereas in homozygous, mom gave one and dad gave the same one. So it'll cause a stronger reaction. Make sense?
Right.
Okay.
Mom and dad give them both, then it's homo. If it's hetero, then mom and dad gave them
Different
one
Yeah.
of different ones.
Yes. So you got your homozygous. So is a double dose of a single antigen. So two genes, same antigen. Now heterozygous is going to be single dose of two single dose of 2 differing antigens. So that's 2 genes coding for different antigens.